Okay, for the second example, so let's make it a little bit more complicated. So previously we have a first order differential equation, this one, so that's why it's kind of short. This is considered short for solving linear equation using Laplace. For the second one, let's have a look at something that is more complicated. So when the order of the differential equation is higher, automatically the calculation is going to be more complicated as well. And even if you notice right here, instead of having one initial condition, now we have two of them because of the formula of the derivative. When you come across the case that you have second derivative for u to the Laplace transform, you have to substitute two initial conditions. So now let's start with Laplace transform both sides of the equation. Now bear in mind our variable is no longer in terms of y, it is actually in terms of x. So first we're going to find what is going to be x of s. So that's Laplace and apply linearity theorem. So I'm going to have Laplace of x double prime. So minus 4 Laplace of x. So that is going to equal 4 Laplace of exponential to t. So I apply linearity theorem straight away now that you are familiar with the calculation already. So Laplace of x double prime, so according to the formula, so it's going to be s square capital X of s minus s x of 0 minus x prime of 0. This is the formula. Please refer the appendix. And minus 4 here again, so this is not just x by itself, this is actually x of t. When you Laplace that, become a new function capital X dependent on s and on the right hand side. So when you Laplace transform this, you will get 4 over s minus 2. It's 4 multiplied by 1 over s minus 2. Okay, next step is substitute the initial conditions. So x naught, the whole term is going to equal 0. X prime 0, this is going to equal 5, right? And terms that are related to x of s, so factorize them both. So here I'm going to have x of s, so multiplied by s square minus 4. And on this side, okay, this term over here, this is not at all related to x of s. So instead of like leaving it on this side, so I actually going to bring it over to the right hand side of the equation. So it's going to be 4 over s minus 2 plus 5, because remember, so the first step is what we're going to do is our aim is we wanted to find what is going to be x of s. So anything not related to x of s, bring it over to the right hand side. Now let me simplify this. Why doesn't it take? No. So here, this is going to equal 4 plus 5. I'm going to put them together. S minus 2 over s minus 2. So if I were to simplify this, I'll end up with 5s. This is going to be 4 minus a 10. That will be a minus 6. And that will all be over s minus 2. So that is what I get after simplifying the right hand side. Okay, so now I'm going to bring the s square minus 4 as well. So I can write that x of s is going to equal 5s minus 6. That is going to be over s minus 2. So multiplied by s square minus 4. So we have reached the first goal, so which is finding the function x of s. So the next step to do is we are going to find x of t, and we know that x of t is simply going to be the Laplace inverse of this term, which is 5s minus 6 over s minus 2 multiplied by s square minus 4. Again, I've told you this before in the previous video. When you come across something with more than one bracket, here I have one bracket for s minus 2, another bracket for s square minus 4, automatically don't think about it complicatedly. This is definitely no other way. It's definitely going to be partial fraction. Okay, but before we start with partial fraction, again, this is a linear factor, no need to check that, but this is not linear. So this is actually a reducible function, which can be written as s minus 2 multiplied by s plus 2. And if you notice, these two, they are the same, so you have to put them together. So now let's start with our Laplace inverse. So let's start with our partial fraction. Okay, let me do partial fraction first. So let's do it over here. So I will end up, my function is now going to be 5s minus 6, and it's going to be over. So let me put s plus 2 to the front, and I'm going to put s minus 2 to the back. So s plus 2 multiplied by s minus 2 square. So it doesn't matter when you order them, if you put s minus 2 squared to the front, so that will be the same. There's no problem with that. Okay, and as what we have discussed in the previous subtopic, so we know that we're going to end up with three fractions. So the first one is going to be a over s plus 2. The second one is going to be b over s minus 2. And the last one is going to be c over s minus 2 square. And now I'm going to form my equation. So I'm going to have that 5s minus 6 is going to equal a. A already have s plus 2, so I'm going to have to multiply a by s minus 2 square. And b already have s minus 2, one of them only. So I need to multiply that by s plus 2 with another s minus 2. And for c, I only have to multiply this by s plus 2. So that is how my equation is going to look like. And from this, we're going to find the value of a, b, and c. Of course, my favorite is always substitution. Here I have two linear factors, which is going to be s minus 2 and s plus 2. The rest is just a repetition of that. So I know that I can come out with two values. So the first value is going to equal s equal 2. Okay, so let's highlight all the places with the s so that we don't miss them out when substituting. Okay, so I'm going to have 5 multiplied by 2 minus 6. So the first term is going to be 0 because of 2 minus 2. This is going to be 0 as well. And then the last term is going to be c multiplied by 2 plus 2. And here I'm going to have 10 minus 6, that's a 4. So 4 is going to equal 4c. So my c value is going to equal 1. So I already obtained my first value. And then I'm going to substitute the second value by using the second linear factor. So I will also have s is equal negative of 2. So 5 multiplied by negative of 2 minus 6 is going to equal a multiplied by negative 2 minus 2. And this is going to be 0. This is going to be 0 as well. So therefore, when I simplify, I'll have negative 16 is equal negative 4a. So my a value is going to equal 16 over 4. That is going to be a 4. So I missed out a square, isn't it? So that's negative 2 minus 2 square. So let's correct that. And this is not going to be 4 anymore. So it's going to equal negative 4 squared. That's going to be 16a. So therefore, my a value is going to equal negative of 1. So please be careful. Don't do such a mistake in the final exam. Okay, so the next is, I already found my two constant values, which is going to be c equal 1 and a equal negative 1. I need to find what is going to be the value of b. Again, you have two ways of doing this. You can either use comparison, or you can also use substitute s equals 0, because we haven't used s equals 0. But I'm going to use comparison because it's going to be easier. I'm going to have, because here I have bs to the power of 2. And if I expand this, I'll get as squared as well. So therefore, the coefficient on this side is 0 because I don't have any s square on the left hand side. But here I'm going to have a plus b. So straight away I can tell that my b value is going to equal the opposite of a, which is going to equal 1. So my b value is going to equal 1. So now that I have all those values, all I have to do is substitute. So my function x of t is going to be the Laplace inverse of a. So that is going to be negative 1. So I'm going to have negative 1 over s plus 2. Okay. And my b value is going to equal 1. So I'm going to have 1 over s minus 2. And my c value is going to equal 1 again. So I'm going to have 1 over s minus 2 square. So that is going to be our Laplace inverse. We have come across something that is similar when we discussed the previous topic from my example. And the first term is going to be negative exponential of negative 2t by using the table. The middle term is going to be exponential of positive 2t, again by using the table. But this over here is not possible to use the table, so you have to use inversion of a shift theorem. So your a value is going to equal 2. So f of s minus 2 is going to equal 1 over s minus 2 square. So please make sure that you show the calculation in the final exam. In maths, nothing comes down from the sky. So you have to show your calculation in order to get the marks. So when you convert this, you will get 1 over s square. And your function f of t is going to equal t. So therefore, the last term when you put them together is going to equal exponential of, remember the formula when this is minus, this is going to be a plus. So Laplace inverse of exponential of positive at, Laplace inverse of f of s minus a is going to equal exponential of positive at multiplied by f of t. So it's going to be the opposite. So where's the, I've written the formula over here. If this is plus, this is going to be minus. So if I have a minus right here, this is going to be a plus. So therefore my exponential is going to be positive of 2t multiplied by f of t, which is going to equal t. So that will be the outcome, right? So as long as you know how to do Laplace and how to do Laplace inverse, so that should be no problem. But usually the constraint for student is that they don't know what method for you to use. For example, you could come across something like this. You could come across something like y double prime plus y equal t exponential of t. So when you Laplace transform, so it's going to look like this. Plus y, and on this side is going to equal t exponential. You have to Laplace transform this as well. And remember, when you have product, automatically you have to use theorems. And here you have t, you also have exponential. So you can either use a first shift theorem or the second shift theorem. So in order to find this. So that's why you have to use back every single thing that we have discussed from 3.1 until 3.6. So everything is related. Okay, so make sure that you get all the knowledge from previously, then only you can start solving this. Alright, so the next video will be the last subtopic for chapter 3, that will be on simultaneous differentiation.